Now to the extraordinary images tonight, the scare for visitors at Yellowstone National Park, the very close call with a geyser raining down rock and debris.
Nature's wonders often come with great danger, and this is especially true for places like Yellowstone.
Yellowstone National Park could be sitting on a time bomb. There is a supervolcano underneath the national treasure that's more than twice the size of the park itself.
Despite recent reports from leading scientists on the very active state of the Caldera, thousands of tourists continue to visit the volcanic site each day, causing many to believe another unexpected disaster is about to hit. But for most people, only two questions come to mind. Why has nothing been done in anticipation? And what do these warnings mean for all of us? Join us as we take a closer look at what the scientists said and all it entails. The recent report. Just early this month, the Yellowstone National Observatory put out its monthly seismic report for November. On the surface, it shows the current volcanic alert level sitting at normal with the aviation color code at green. But the many seismic activities mentioned in the report raises a lot of concerns. To unravel the hidden implications of this report, we have to briefly go back in time to November 2004, a time when major signs of an imminent disaster were on the horizon, but were largely dismissed as normal because of the far bigger warning signs in the past 50 years that didn't lead to anything. Sadly, things went horribly wrong, as on December 26th, a powerful tsunami struck the west coast of northern Sumatra, Indonesia, taking thousands of lives and homes along the way. Now it seems history is about to repeat itself, as the experts at Yellowstone are doing the exact same thing. Many warning signs are on the horizon, but only a few of them see them as a threat. Here is how. As we know, last month was a very busy month for the scientists at Yellowstone. This was mainly because of a very high spike in minor earthquakes, prompting many experts to expect increasing seismic activities in the coming weeks. Throughout the month, Yellowstone experienced a total of 88 earthquakes, with the most devastating occurring on November 7th. Just 2 days before then, there was a hydrothermal explosion at the Black Diamond Pool, one so powerful that it sent large rocks over 20 feet into the air. But not even that compared to what occurred during the final week, particularly from the 26th to the 28th. Simply put, it was a nightmare for the scientists at the observatory, as there was a seemingly endless swarm of over a dozen minor earthquakes that raised a lot of concerns. Because of this, many other experts were called to keep an eye on things while they put out a report on everything they observed in recent weeks, and the details were unbelievable. With almost 90 seismic events recorded and no major steps taken in anticipation, many see the recent report and subsequent reactions as 2004 repeating itself. But besides minor earthquakes at various places, many leading geologists, including famous geophysicist Michael Pollan, believe that an imminent major eruption might be underway if 5 major indications are occurring at similar volcanic regions at the same time. First of all, major ground swells have to be occurring at various places in the area. Secondly, there should be major spikes in temperature at geysers and hot springs scattered around the caldera. Thirdly, there would also be very unusual behavior among animals living in the area, usually involving many species running from their habitat due to the increasing temperatures. Major erratic bursts of steam and other gases should also be observable from various places. And finally, there would be huge cracks appearing at various places across the landscape. To better understand the full extent of these warnings, let's now examine each of these signs and what they mean for the caldera, ground swellings and heat spikes. While most Americans might remember November 5th as a major turning point in modern politics,
now officially project that Donald Trump will become the 47th President of the United States.
It was a whole different day for the scientists at the park. It was the day Yellowstone experienced its first major sign of eruption for the month, marking a huge moment for the National Observatory. In simple terms, it is what happens when the intense heat from volcanic activity causes the Earth's very hard surface to behave like an elastic balloon. If you feel stuck thinking about it, chances are that it is just as frightening as it sounds. It was captured by the various GPS stations close to the Yellowstone caldera and near Norris Geyser Basin.
This is station P711. It's a GPS station. What we've got is the GPS antenna that's mounted on this very sturdy support here. It's sturdy because we want to look at very, very small changes in ground deformation over time.
A lot of these swellings also happened very slowly, with some beginning from early October. With 2 decades of experience at various observatories, Dr. Michael Poland explains this, stating how major ground swelling like these hints at an impending eruption. According to Dr. Poland, underneath Yellowstone is a huge reservoir filled with molten rock under very high pressure. This molten rock, commonly known as magma, is formed when solid rocks are forced to move upwards. As the pressure reduces, the solid rocks melt and become liquid. The same thing happens with tectonic plates, where ice chunks that exist at the bottom of the sea turn liquid as they come up to the surface. So with the molten rock being lighter than the solid rocks around it, it naturally floats upwards, accompanied by the intense pressure that forces it in that direction. This usually happens when the magma finds a path through which it can reach the surface. But when there is no path, the molten rock forces its way upwards, causing major ground swellings at various places surrounding the mighty Caldera. And that is exactly what was observed on November 5th. With one box ticked, this leads us to the next big sign of an imminent eruption, and that is major spikes in temperature in various places. We can easily tick this box with the various temperature spikes occurring currently at the Norris Geyser Basin, Mammoth Hot Springs, and Midway Geyser Basin. These happened throughout the month, with the most shocking spike occurring on November 5th and 26th. Dr. Mark Stelton, deputy scientist in charge of the observatory, reported that these springs suddenly went a lot hotter than usual. For context, before the sudden increase, most of the springs averaged at about 200 degrees Fahrenheit. But on November 5th, temperatures increased by over 100 degrees in a matter of hours, settling at just over 345. This was way too sudden to be taken lightly, and he explained that it was caused by the quick heating of the water around these areas of rising molten rock. This sudden surge in temperatures implies that the magma is rising much quicker than normal, and while this alone isn't enough to prove a major eruption is slated to happen anytime soon, it stands as a warning when associated with the other factors. Dr. Robert Smith, another geophysicist from the University of Utah, wrote about this in great length. His studies show that while this alone isn't enough proof, it usually came before the major eruptions that have occurred in recent history. This presents a problem with the current scientific standard, as past major eruptions show that not all 5 indicators have to be present for an eruption to occur. According to Dr. Smith, the best way to arrive at a good conclusion is by learning from history, not just relying on modern monitoring techniques that aren't completely reliable. The air is still a lot more to reveal: hydrothermal explosions and unusual animal behavior. Other events that made history and raised a lot of eyebrows at the observatories include the strange behaviors of certain animals at Yellowstone, most particularly among the bison, elks, and wolves. As we know, Yellowstone, like most other mountainous regions outside the tropics, can be very brutal on animals during winter, a time when those places become very cold and food becomes difficult to find. Due to the higher presence of food, bisons are known for living in these elevated regions, but from November 5th, experts and the Yellowstone Observatory noticed that these animals were now moving to lower places in the region, despite not having as much food as they would in the higher places. Due to the harsh winter, these bisons found warmth in the lower places where the hot springs and geysers were suddenly heating up. In contrast, elks moved to the much colder regions of the park. They preferred to stay in places that weren't affected by the volcanic activities. The wolves, on the other hand, mostly took the same routes as the bisons, often preferring to stay in the much warmer regions, as it helped them become more active with hunting and other activities. They were found in many places they normally wouldn't be, including places near the Midway Geyser Basin. For better understanding, this was explained by Professor Mark Boyce, a renowned ecologist who worked at the observatory. He pointed out that animals are very sensitive to environmental changes, sometimes much better than humans. In this case, they noticed the sudden shift in temperatures occurring in the area and adapted accordingly. This, according to Dr. Boyce, most likely points to a sudden surge in volcanic activities in the area, as he noticed this among the new gray wolves introduced to the park barely a year ago. This leads us to our next big indicator, the unexpected bursts of steam and other gases from various places. And as usual, Yellowstone ticks this box very easily, especially considering the multiple dangerous hydrothermal explosions that occurred on the 5th and 26th of November. These explosions are caused by the forceful breaking forth of underground steam, powerful enough to send full-grown adults hundreds of meters into the air. Thankfully, no tourists were close enough to experience this, as Yellowstone officials have learned from previous experiences not to let visitors anywhere near these places, but the nearby boardwalk and benches were destroyed. Many clues link this to a potential eruption, including major insights given by Dr. Michael Stelton, a renowned geologist working with the United States Geological Survey. Dr. Stelton gives two possible causes for these explosions. He argues that either the natural plumbing system is clogged or the water is heated by the molten rock. For the first instance, he explained that places like Yellowstone have natural channels where water flows underneath the ground. When the water gets blocked by expanding rocks along the way, it heats up and turns into steam, and the intense pressure from this quick transformation causes the explosion. For the second explanation, Dr. Stelton agrees with most other experts at the observatory by pointing to the molten rock under the surface as the main cause. When the molten rock heats the underground water, it quickly becomes the steam that quickly builds up pressure before breaking forth from the Earth's surface. As we've seen, thanks to the input from trusted scholars and experts, Yellowstone ticks yet another box. Now, we are one step closer to a full-scale warning from nature about an imminent threat. Stay tuned as we look at the final indicator for this imminent catastrophe: visible cracks and devastating implications. Earlier on, we talked about ground swellings caused by molten rock that make the Earth's surface behave like an elastic skin, but that when the Earth's surface reaches its elastic limit, it cracks. And these cracks have always been rampant at various points around Norris Geyser Basin, Mammoth Hot Springs, and Midway Geyser Basin. As always, these cracks began to form on November 5th and became most obvious to onlookers by the 26th. Dr. Michael Poland and the other scientists investigated these places and collected samples. They took measurements and wrote down their reports, and after over a week of intense study, many of the readings and conclusions alone implied there was nothing to be worried about. But when accompanied by the other factors, Dr. Poland understood the need to make things clear. Much of what he explained aligned with what we've discussed, linking the cracks with rising molten rock and intense pressure.
Well, it's almost been a week since a hydrothermal explosion at Yellowstone National Park. NBC Montana's Brianna Henderson spoke with an expert from the Yellowstone Volcano Observatory to unearth more about the natural phenomenon.
As you've seen, Yellowstone meets all the requirements to be considered a potential threat. This causes many to wonder why there have been no strict measures taken in anticipation of this catastrophe, and the reason so far is that recent history shows far greater signs that didn't amount to anything. Because of this, those at the Yellowstone Observatory decide not to call for an emergency until all indicators reach a highly critical level, one that hasn't been observed in over half a century. Until this happens, all simultaneous seismic activities are seen as normal, and as far as the experts are concerned, there is nothing to worry about. But if past events have taught us anything, it's to be prepared at all times in situations like this. So what do you think? Is there truly nothing to be worried about? Is there any point in getting prepared?
After the extremely devastating 1906 San Francisco quake, he was tasked with investigating its source. To do this, he surveyed the surface ruptures, including offsets such as fences or roads sliced in half, and plotted their locations on a map. He noticed that these offsets aligned perfectly with the fault he had previously identified, leading him to conclude that the fault was responsible for the earthquake. Interestingly, this discovery also led to identifying a new type of earthquake known as an intermediate depth earthquake. Although the visibility of the San Andreas Fault can sometimes be problematic, much of the San Andreas Fault's length is visible as a straight depression. This has produced a characteristic pattern of lakes, bays, and valleys. These qualities may not be immediately apparent from the ground. For instance, drivers may need to be informed that they are in the San Andres earthquake zone as they pass close to Crystal Springs Reservoir near San Francisco, Tomales Bay, or through Cajun or Tejon passes. The location of the fault on the Earth's surface can be determined by carefully examining the landscape in the area. Moreover, in some places, like the Carrizo Plain in San Luis Obispo County and the Olimatrof in Marin County, the San Andres Fault is clearly visible as a succession of scarps and pressure ridges. Wickedly destructive and potentially still so, this fault is the most dangerous in America. With the number of lives it has claimed and could still claim, there is possibly nothing like it in the world currently. Fast back to over 600 years, it released earthquakes like a mother dishing out candies to have a poor little baby. Somehow, that has since stopped for a while. In fact, current data shows that since 1857, Southern California, the hub of the fault, has never recorded any earthquake. To know how heavy the earthquake around this place can be, we are sorry to announce that the one of 1857 had a magnitude of 7.9 and resulted in damage along a stretch of about 185 miles, taking the total lives possible in that area at that time, and destroying some other things. Unfortunately, the recent drought of quakes has led many scientists to think the probability of an imminent quake is ever higher than necessary. In fact, according to some, the coming one will be a big one because of the drought. Thus, given the strains and pressure it has collected over the years, the fault remains a time-ticking bomb that may devastate things. The Pacific and American tectonic plates meet near the San Andres Fault's border. These two plates remain in constant contact, creating pressure that finally manifests as earthquakes and causes catastrophic loss of life and property. Elastic rebound is the name of the entire process. These cause seismic waves, which move through the earth and shake the surface as they collide and crash into one another. That is why the San Andres Fault in Northern California can experience an earthquake, but not the San Andres Fault in Southern California. Is California going to be swallowed up anytime soon? First, you'll perhaps like to hear this. The already identified upcoming large-scale earthquake, or the big one, as it is generally known, won't be this deadly California swallowing core that we are being told will happen. In light of current research in the field, except for the economic drawback it will cause, this earthquake will be far from its predecessor, the one of 1857. There are very good reasons for this. Since we do not mind keeping you in the dark, let us observe them closely. First, structures. In quakes, the death caused by structures falling apart is more than those caused by the shocks and tremors of the quake themselves, except in the case of house-swallowing ones. The Southern California administration, noticing this many years back, has embarked on a nationwide principle-backed construction of houses and other structures that will make them unable to be destroyed by quakes. This does not mean structures can be totally earthquake-proof. It just means, given the fact that the earthquake might not be that strong, and the fact that structures in California are constructed in accordance with some of the most stringent seismic resistance regulations in the world, the earthquake having an ultra-destructive impact, as is often portrayed, is unlikely. Meanwhile, state infrastructure, such as electric power, communication masts, and more, is expected to be extremely damaged by the quake since they cannot withstand it. This will stop communication flow abruptly until something is done to it. Corroborating this is people undergoing significant research. Of course, this does not mean everything is in place. Let's turn to what some scientists do to predict what could happen. First, in a bid to understand the future scenario of the quake, they adopted the 1989 Loma Prieta earthquake as a model, and the result is the same as what has been said earlier, albeit with some differences that will be mentioned later. The IT industry will experience communication problems for a very long time. But what if it is struck hard? What could happen? In that state, the 1989 Loma Prieta quake can explain many things. During the above earthquake, more than 60 people died, and another 3,000, 800 were injured due to its epicenter roughly 10 miles northeast of Santa Cruz. A significant motorway collapse and the devastation of around 40 buildings in Santa Cruz were among the damages. To get the scenario, we must also mention that the U.S. Geological Survey reported that 12,000 residences and 2,600 businesses were damaged or destroyed throughout the San Francisco area, and that the overall cost of the earthquake was $6 billion in 1989 currency. According to John Woodall, Vice President of Engineering at Integrated Arco Systems, a Palo Alto, California-based solution provider, the roadways around the epicenter of a prospective earthquake area could impede recovery efforts due to the state's substantial population, especially so in the case of the San Andreas Fault. The danger becomes even more apparent when you realize that the fault lies on the boundary between the American and Pacific tectonic plates. This is regarded as the most dangerous. Why is this so? The fault runs directly through cities, including Desert Hot Springs, San Bernardino, Wrightwood, Palmdale, Gorman, Frazier Park, Daly City, Point Reyes Station, and Bodega Bay, which makes them vulnerable to earthquakes at any time. In the case of the big one, consider them gone. When could the next earthquake occur along the San Andreas Fault? Every year, thousands of minor earthquakes in California give scientists a clear idea of where faults in the Earth's crust are. The earthquakes in 1857 and 1906 were the two greatest ones recorded along the San Andreas Fault. The Southern California earthquake of January 9, 1857, had a similar magnitude to the 1906 San Francisco earthquake. According to newspaper accounts, ground movement in both situations was comparable. A sheep coral cut by the fault was described as changing from a circular to an S form in the history of the 1857 earthquake. This movement is unmistakably indicative of a right lateral strike slip. Analyses of offset stream channels show that in 1857, activity reached a height of up to 29 feet. This sparked a flood of research on the San Andreas Fault, greatly advancing our knowledge of the fault and general geology. Over 3,000 studies on the problem have been published in the previous 24 years alone. Over 700 people died from the San Francisco earthquake and fire on April 18, 1906. Millions of dollars were damaged throughout California, from Eureka South to Salinas and beyond. Even central Nevada and Oregon could feel the earthquake. The 1906 earthquake, recorded as having a Richter scale magnitude of 8.3, produced intensities as high as 11. A 250-mile section of the fault, from San Juan Bautista north, across Point Arena, and offshore to Cape Mendocino, experienced surface offsets. A 7.1 magnitude earthquake struck the Imperial Valley on May 18, 1940, along an unidentified fault. During an earthquake in November 1979, the Imperial Fault experienced a similar movement. The largest surface displacement was the right lateral strike slip displacement of 17 feet during the 1940 earthquake. This fault is undoubtedly a component of the San Andreas system. On the Haywood Fault in 1836 and 1868, as well as on the San Andreas Fault in 1838, there were further earthquakes with probable magnitudes of 7 or higher. There are sections along the Earth's plate boundaries, like the San Andreas Fault, where no significant earthquakes have struck for a long time. Scientists refer to these sections as seismic gaps and have generally been successful in predicting when some seismic gaps may result in significant earthquakes. According to geological studies, the southern San Andreas Fault has experienced significant earthquakes during the past 1400 to 1500 years at intervals of roughly 150 years. The south of the San Andreas Fault is a plausible spot for an earthquake within the next several decades, because the last significant earthquake occurred in 1857. Even though it has just been a little over a century since the devastating earthquake of 1906, the San Francisco Bay Area is still susceptible to moderate-sized, potentially destructive earthquakes. The necessary fuel for a large earthquake of the magnitude of M8.0 has been built up over 159 years and 26 feet of tectonic displacement. As the strain becomes too great for the surrounding rock's tensile strength, the rock holding the strain will eventually break. At this time, the two plates will abruptly reach equilibrium, or a state near equilibrium, forcing the plates out of their current position. A significant earthquake might not happen suddenly. Increased seismicity over the years, foreshocks with a magnitude of 5, may occur before such an earthquake. Seismologists anticipate observing changes in the Earth's surface before the next significant quake, such as the shortening of survey lines across the fault, changes in elevation, and impacts on strain meters in wells. The part of the San Andreas Fault near Parkfield in Central California, where a moderate-sized earthquake has occurred on average every 20 to 22 years for roughly the last 100 years, is a crucial place for study on earthquake prediction technologies. There is a significant likelihood that Parkfield will experience an earthquake of magnitude 5 to 6 before the end of this century, because the last sizable earthquake struck in 1966. To understand what changes may occur before an earthquake of that size, the U.S. Geological Survey has set up various devices in the Parkfield region and carefully analyzes the data it has acquired. According to scientists, the San Andreas Fault can cause a powerful earthquake of 7.0 or higher at any time. According to paleoseismic analysis, the last significant earthquake in the southernmost region of the San Andreas Fault occurred in 1726. According to Bahan, a fault cannot actually be overdue for an earthquake, although this one hasn't had one in a very long time. This can signal an impending rupture. Bahan concurred that the longer a period passes between earthquakes, the more time there is for a strain to build up and an earthquake to occur. The researchers had to spend years dating the motion of old earthquakes to determine the fault's slip rate. They used geochronological dating techniques and field mapping to determine the fault strand's motion. They could estimate how much the faults had migrated by mapping and dating rocks and dirt from ancient river channels. This allowed them to calculate slip rates. This clarifies which fault strands are active and likely to result in future earthquakes. Yet, the San Andreas will almost certainly cause a big earthquake in the not-too-distant future. When it does, there will be major devastation and a significant impact on Southern California. But these occurrences are not unfamiliar to Californians, and recently, the state's infrastructure has been built with earthquake protection in mind. The region could be out of commission for a considerable amount of time, so forget about tsunamis and deep chasms springing out. But do prepare for strong shaking, structural damage, fires, and significant economic consequences. As it will inevitably occur at some point, the question will ultimately come down to when, not if. Large earthquake systems, like California's San Andreas Fault, are thought to be propelled by immense forces that are only controlled by friction along the fault that is almost as powerful as the forces themselves, according to years of geological evidence. The idea has been emphasized in textbooks that train generations of Earth scientists, and most geologists today have no reason to question it. But today, the textbooks probably need to be more accurate. However, recent research reveals that the friction that restrains the massive San Andreas Fault is so weak that it would only require the geophysical equivalent of a light prod, not strong forces, to send the fault rumbling in its direction. Yet, the research also hints, albeit hesitantly, that the San Andreas is not about to disintegrate into big pieces. In addition to being weak, the forces that cause the fault are often focused in the wrong direction, according to strain studies along the fault system. The new data may make the San Andreas more or less likely to rupture shortly. Therefore, none of that necessarily means California is better off or worse off. The unexpected findings answer certain long mysterious geological phenomena, but also raise important new concerns regarding the dynamics of the fabled San Andreas system. According to scientists engaged in the study, the findings indicate that significant reorientations of stress patterns along the San Andreas would be required before a catastrophic earthquake could occur on the fault. In the coming years, significant changes in such stress patterns may be crucial in assessing whether a dormant stretch of the fault is ripe for an earthquake, according to Stanford University geophysicist Mark Zoback. Ironically, a deep research well on the Cajun Pass, located just 2 miles from the fault, will be shut down in the coming days due to a lack of funds, which was one of the key methods to reach those results. Scientists will feel uncomfortable with the data gathered because drilling will be stopped just a few thousand feet above the fault, leaving some crucial data gaps. According to Zoback, the project's principal scientist, the well, which is currently 11,000 feet down, has shown that the tension is practically 90 degrees in direction from what we predicted. That would likely push the issue in the wrong direction. In that sense, it's similar to a warning sign. No tension is pushing the fault in the right direction, as should be the case. If we can't prevent it, are there some ways we can actually prepare for this earthquake to reduce its harm? Although there is no perfect way to totally prepare for earthquakes, some things can still decrease the weight of their havoc, and what's more, even keep you alive if, God forbid, you find yourself in one. Fortunately for us, the first is being done by the administrative unit overseeing the San Andreas and the surrounding area, fortifying houses with seismic-proof technological resources. But they still need to do more in the case of old houses. We need to find out how much technology can help in this case, so we must take care. Considering their susceptibility, a program for their demolition should be created to build new ones in their place. Something must be done to them because they are very, very dangerous standing like that. In fact, it is better for there to be no house than for there to be a house. The second one is more or less like the first, but of course, quite separate. New houses should be built with seismic construction systemic methods. We are not talking about technological devices. We prefer safety measures that are part of the buildup of the construction. Of course, technological appliances can also be used to fortify buildings. Now the third is which will be useful for anyone living in this area. It is divided into two. Seismologists must be so nimble that they can predict near-accurate precision when an earthquake will happen. The second is that when such an earthquake prediction is given, evacuate the place as soon as possible. Even if it doesn't happen eventually, you will live to see it. Being out of harm's way in a situation like that is more beneficial. Meanwhile, we must commend the government for the Earthquake Hazards Reduction Act of 1977, which marked the beginning of a substantial program being carried out by the U.S. Geological Survey, other government agencies, universities, and private groups to learn how to forecast earthquakes and assess and reduce their dangers, and we hope this helps.
Let us know in the comments down below. If you enjoyed the video, make sure you like, share, and subscribe. Also, click the next video shown on your screen. You will enjoy it.